Welcome to a short webinar presented to members of the Southern region of the International Plant Propagators Society. Today's webinar is focused on preliminary efforts by a collaborative team which is trying to evaluate the use of small drones to collect plant inventory using RFID tags. The research project team is led by Dr. Tom Fernandez at Michigan State University. Other members on the project team are Dr. Joe Marie Maha at Clemson University, Dr. Matthew Chappell at the University of Georgia, Dr. James Owen at USDA Worcester, and Dr. James Robbins at the University of Arkansas. The project team also includes some key commercial partners, including Avery Dennison. This research project is partially supported by a grant from the Horticultural Research Initiative. The project was supposed to start at R.A. Dudley's nursery in Thompson, Georgia in mid-March, but as we are all aware, COVID-19 will delay the start until spring 2021. The purpose of this webinar is simply to give a glimpse into some of the preliminary work going on. The challenge for this team was identifying an RFID reader that could be attached to a small drone. The left side of the screen shows the RFID reader, the custom-built reader frame, and an example of one type of RFID tag provided by Avery Dennison. The right panel shows the drone, which is a DJI Matrice 600 Pro. Again, remember, this is simply a demonstration of some test flights to evaluate the drone RFID system. Credit goes to Dr. Maha at Clemson for preparing all of these systems and his wife Mimi for editing the demonstration video. For this demonstration, the drone was flying at 6 meters or 20 feet above cotton field at a forward speed of 6 kilometers per hour or 3.7 miles per hour. In total, the drone was flown at 3 test altitudes. RFID tags are hanging from stems of the cotton plants. In the upper left, you can watch the live dashboard, which is streaming information in real time. The panel in the upper right highlights the tag information as it is streaming. The next video illustrates how we plan to evaluate the effect of flight altitude or distance from the RFID tags on readability. In this example, the RFID tags are sitting on the ground in the middle of the road, and the drone will pass back and forth over the tags from a left-right to right-left pattern. There are 2 markers on either side of the tags, which are simply being used by the licensed pilot to navigate the course. The licensed pilot and observer are currently behind the camera. The video has been sped up and does not reflect actual aircraft speed. Again, remember, this is just a dry run of the general system. The final experiments will be at a commercial nursery and involve more rigid and defined parameters. Notice at this time, just doing kind of a preliminary test of altering the altitude from 4.5 meters to 6 meters to 7.7 meters. This last video is similar, but in this case, RFID tags are hung on field plants. In this case, you can see the licensed pilot and the observer. Again, using a similar approach, there are two markers just to help the pilot just navigate efficiently over where the tags are located. These are just some preliminary sweeps to just investigate what kind of tag information we can extract from different positions. Again, at this point, just trying to assess our ability to capture some preliminary tag information. The collaborative research team hopes you enjoyed this short presentation about merging RFID tags with a small drone for inventory of plants in open field settings. We look forward to sharing our research results as the project moves forward.